All right. So as I was saying earlier, if you ever get a trig equation with different arguments you're trying to solve, you need to use your trig identities to generally convert the larger arguments into the smaller. So we're going to need a trig identity for cosine of 2x, and there are 3 of them. So cosine of 2x equals, if you only remember one, let it be this first one. Cosine squared minus sine squared. Because from this one you can get the other two forms. We know that cosine squared would be 1 minus sine squared, trig identity. So what do we have here? 1 minus sine squared minus another sine squared. Okay. Do the same trick with the sine squared. We know that sine squared is 1 minus cosine squared. So if you replace sine squared with 1 minus cosine squared, you get 2 cosine squared minus 1. Okay. So we're going to use this trig identity. So we get to choose between these 3 different forms of cosine of 2x. And one of the things I said earlier is that it's nice to solve trig equations with all the same trig function. So I see this other term as a cosine term, so I'm going to use the trig identity that involves only cosines. Get it all down to the same trig function. So replace your cosine of 2x with this. Keep the 3 cosines. Keep the plus 2. Set it to 0. Simplify, never leave 2 minus 1. And try to factor. This is quadratic in cosine, so I guess substitute u for cosine. Under this substitution, our quadratic becomes back substitute for cosine. Set each factor to 0. This gives cosine negative 1/2. Set the second factor to 0. We get cosine is negative 1. Cosine equals negative 1/2. We can draw a triangle for this. We know that cosine is an x value divided by a hypotenuse, so I will draw 2 triangles, each with an x value of negative 1. Each with the hypotenuse of 2. All right, again we're dealing with the 1, 2 square root of 3 right triangle, and we care about the reference angles. And we see that these are the angles opposite of the side magnitude root 3, so pi over 3. Okay, so the angle's off the positive x-axis. Well, if we start here and travel around to here, we have gone a total of pi radians. Then we would need to backtrack by pi over 3. And that would give us one solution of 2 pi over 3. starting here at 0, travel around pi radians, and keep going by pi over 3 produces pi plus pi over 3, or 4 pi over 3. Cosine x equals -1. There's no triangle for that. You need to use the graph. Here's cosine. Cosine we see is -1 at pi. So from this one here, we get x equals 2 pi. So we'd have 3 roots between 0 and 2 pi.